today. I'm going to give a very brief introduction on myself and obviously Cork Institute of Technology and the drivers for our adoption of Dynochem within our curriculum of chemical engineering, how we've tackled a first year practical, a second year practical, the project applications we've had under our research chemical engineering projects, and any suggestions or questions would be most welcome towards the end. I suppose my perspective is very much incorporating it at a student level whose knowledge and maybe experience wouldn't be as vast as others in terms of chemical engineering, particularly in the processing side. So I suppose my target audience is very much people who are interested in implementing Dynochem at an undergraduate level. So you mightn't have enough meat for those who are the super users out there, and I know there's a lot there. So that was a push for me then to start incorporating it into our first year curriculum. So we did that successfully in 2014, developing a lab that would be suitable with the skill set that we had. With that then, I think last year we ran a second year application of it, and then also as well concurrently had the final year projects in terms of design and research ongoing as well. So it's a relatively a short journey, and I'm sure the journey is going to continue, but that's our journey to date on where we have been. So I suppose next really at this stage is to start talking about how we incorporate it into the first year chemical engineering labs. Generally first years, our first years, they come in and they do very much abroad at semester one. In semester two, we really take them into the throes of chemical engineering by doing 7 hours a week of process engineering labs with these students. So early in the semester, they do quite an intensive lab in terms of mixing. And essentially in that lab, they look at very much a simple stir tank reactor, look at the agitation speed and the power consumption that is being drawn off by the impeller. Task of the student is to solve an unstructured problem, and that was Fergus's problem. We have a depth filter in our chemical engineering lab, which is for liquid solid separation of an aqueous suspension. It was an area that I was quite interested in myself because I lecture in the biopharma processing. Filtration is very prevalent in biopharma, very much in upstream and downstream processing. So I felt this was an area that we could possibly add a lot more competency within our department. So Fergus held the charge just to start on maybe just separating out a very simple process. So this lab, I suppose, our research project has its fundamentals with the Darcy equation. Our students generally do a full module on particulate systems, so they would have done the theory on the Darcy equation, which obviously is the workhorse that allows us to start, I suppose, simulating a depth filter in Dynochem. So our students would have done this particular module in second year. So I suppose Fergus had to revisit it as part of his research project. With that, his task then was to, I suppose, visualize it, and Dynochem have a very good visual package of what you're to separate. So we had a slurry, which was kaolinite in water, and then obviously to form a cake, which, as you appreciate in the depth filter, would be quite large, and to filtrate it, which is an aqueous solution. First of all, to the CIT Chem Eng group, I have been very fortunate to work with a great bunch of people. They probably should get an award for best place to work. I've worked in a lot of industry, and I must say I haven't regretted jumping over to the Rubicon. In terms of their collegiality, their support, healthy debate, and also as well the fun that we have had has always made the job very, very interesting for me. Also as well to our fantastic graduates and also our current students, Fergus O'Brien, Roisin Kelleher, Norma O'Malan and Ken Student have really, I suppose, for the last 2 years have helped me to upskill in Dynochem. And to be honest, there's been a huge amount of knowledge transfer from the student to me as well as I transferring to the student. So it's been very much a symbiotic relationship, and we've had some fantastic students, and I'd like to compliment them on their skill set, and they have obviously, their employers have recognised them. They are now thriving as competent chemical engineers out in the workforce. I would like, I suppose, to thank the industry, I suppose, for pushing us in CIT to incorporate Dynochem into our program, and it's been very beneficial for us. It's given us great capability, great confidence. Our bar in terms of research and design projects has risen, and I really would like to thank the employers for pushing us, and it's been very much a pull from us, I suppose, to incorporate it.